A very good morning to Doctor and all my friends. I'm Huawei. Today my proposal topic is synthesis and characterization of dimethyl phthalate-based imprinted polymer via electrochemical polymerization. My supervisor is Dr. Mo. Background study. Dimethyl phthalate is widely used in plastic and pesticide and also the personal care product. However, it is well-known pollutant, so it can easily leak into the environment matrix due to its water-soluble characteristics. So we have some analytical techniques to detect some unknown pollutants like HPLC, GC, MS, and so on. But they are pricey and also time-consuming. Therefore, you use the EMIP method to detect it because they have the high sensitivity and also the selectivity because they have the similar shape like the enzyme substrate complex. Problem statement. Plastic enter into the marine ecosystem. The possible consequences including the release of some constituent like the additive. So the dimethyl phthalate is created as a plasticizer, well-known new pollutants. So we use the EMIP sensor to detect the DMP or in all the environment metrics. And we can take earlier action to detect the changes of DMP. So cyclic watermetry and also some of the analytical technique to check the characterization of the EMIP sensor. Objective. First objective is to determine the capability of EMIP to absorb DMP and characterization of EMIP and nanomaterial use. Next is to generate a quicker, more stable, sensitive, and cost-effective EMIP sensor that can exhibit excellent identification, capability, and sensitivity. Literature review. We have 4 uses of DMP: pesticide, plasticizer, moisturizer, and solvent, and so on. This one is common in our market. Next is the implication of DMP towards human health and environment. Human health, we have, because the DMP acts as the endocrine disruptor and also it can act as the interference in the reproductive system. For the zebrafish, the endocrine system is already disrupted by the DMP and also genotoxic and phytotoxic effect in duckweed plants and so on. EMIP sensor optimization, ratio of dimethyl phthalate and pyrrole. The parameter that can identify the ideal template and also the monomer ratio is like peak current difference. Overabundance of the monomers in the EMIP layer can reduce peak current and by the interference with the DMP detection and also its removal process. EMP does not bind to the low monomer concentration because it leads to the formation of MIP with low DMP attachment. Redox probe solution like potassium ferrocyanide must be used. Electropolymerization cycle number is necessary to make polymeric film is neither too thick nor too thin. Optimizing the number of the cycle is necessary to obtain the optimal film thickness for DMP detection. A thin layer of EMIP may result in unstable cavity and also they can prone to cross-react with the interference. Repeated polymerization cycle can result in thicker film and also fewer accessible pretty spot. Next, we have the electropolymerization rate. Decrease in the number of cavity in EMIP, restricted diffusion of DMP into the electrode surface can result from the low polymerization rates. When a fast polymerization rate, the orientation of the cavities printed on the EMIP film is changed. Next, we have the template removal cycle. The over oxidation technique is used. This reaction forms a lot of the functional groups such as the carboxyl carbonyl group and so on. This group synthesis lowers the MIP electrochemical properties and also release the non-covalent link between the MIP and also the template. Cyclic watermetry may determine the over-oxidation cycle number. Analytical instrument for characterization of EMIP, we have XRD, FTIR, and also SEM. SEM is to detect the microstructure and also morphology of the material. The total functionality and the performance of EMIP are determined by their chemical and morphological structure. FTIR is to assess the chemical structure of EMIP that are particularly connected to the interaction between the functional monomer and the template molecule complex. XRD is to check the material underlying the crystal structure and permits confirmation of a sample crystallinity and the structure, but it provides no chemical information. Next, analytical instrument for electrochemical characterization of EMIP. We have CV and the EIS. CV, we use the potassium ferrocyanide as the redox probe to examine the alteration in the electrode behavior following each stage of a sensor assembly. The reversible redox reaction of the redox coupler can be utilized to investigate the electrochemical performance of the bare electrode or also the modified electrode. EIS, it can detect the polymer coating, and the polymer coating serves as a barrier to stop the redox species from permitting the electrode, which alter the electrode's capacitance and also the electrochemical impedance. Methodology. These other chemicals and material will be used in the study. Same thing with the apparatus. Multi-wall carbon nanotube preparation. This nanotube must be prepared because it can enhance the electrochemical properties of the electrode. And then 1 gram of the nanotube is will be weighed and also submerged in the concentrated nitric acid. After that is start to ultrasonicated for 4 hours straight at 65 degrees Celsius. To wash the solution, we need to use the deionized water. To create the acidified nanotube, the solution will be filtered and also dry for 1 day in the oven. 1 ml of DMF will combine it to become the suspension. Preparation of the nanotube and the pencil graphite electrode. How the nanotube is deposited on the pencil graphite electrode, so we use this procedure. Distilled water will use to clean the electrode and also sonicate for 1 minute. And the electrode will use an oven to dry at 30 degrees Celsius for 30 minutes. And also 2 mg of the nanotube in ethanol solution will sonicate in ultrasonic bath for 30 minutes to alter the electrodes. After that, a functionalized nanotube solution containing 9 microliter will be used and deposit on the electrode using the drop casting. So this is the preparation. After that, we have preparation of pencil graphite electrode with the nanotube and also the MIP. Same thing with pencil graphite, nanomaterial, and also the MIP. So the pencil graphite electrode is act as the working electrode, and the PT electrode is act as the counter electrode, and also the AgCl is a reference electrode. So this is the procedure how we prepare these two electrodes. PAPG electrode and also other electrode preparation and sample analysis. So we have SEM analysis. We need to create a lightweight film, so we need to remove the larger part of the ore electrode. After that, scanning electron microscope, we just to set the 10 kilowatt accelerating voltage to build the sample. ATI FTIR does not require the sample preparation, just to set the range between the 500 cm power -1 and also 4000 cm -1. And with the resolution 4 cm -1, after that 64 scan to increase the sensitivity of the spectrum. Cyclic photometry and also the XRD analysis. XRD analysis is to use the mortar and pestle to produce ultra thin film. And after that, liquid medium must be used. And also the cyclic photometry. Before we start to measure, we need to have the electrode be in the dry condition. And 0.5 m KCl solution and 5 mmM redox coupler will be immersed inside. And cyclic photometry will be set between the negative 0.4 volt and 0.8 volt. The scan rate is 50 millivolt. And also the EIS just to set the frequency range between them. After that, the instrument has an applied potential, which is a 0.2 volt. And after that, all electrode or each electrode will be immersed in the DMP solution before and after the template removal. So next is expected result. We just don't need to find out all the parameter in suitable range that can optimize one of the EMIP sensor. And also we need to create some cavities in EMIP and also some MIP, and removal of the template before and after of oxidation can be determined. The degree of crystallinity of the nanotube of both before and after electropolymerization can be measured, and also differentiate between the bare electrode and also the modified electrode. This is a flow chart, and after that, proposed timeline, and this is the reference. After that, thank you.